I'm Davide, and I work with the Energy Transition and Environment Unit at Facoetti, using machine learning to gain insight into smart electricity meter data and how to translate that into commercial applications. This week, we all had a powerful reminder of how climate change is affecting our lives. It's a complex challenge that requires a complex mix of policy and technological solutions. When we talk about the energy transition, we all think about the amazing technology that allows us to produce cleaner energy, but we also need to improve how that energy is distributed and consumed. One piece of the UK government's strategy to drive this transition is the rollout of smart meters. By 2025, all consumers will be billed based on when they actually consume energy, with half-hourly settlements. This will change dramatically the way in which utility companies trade energy, design new tariffs, and so on, and will also give consumers the opportunity to adapt their behavior to take advantage of when electricity is cheaper. To make the most of it, we need to understand the huge amount of data generated by smart meters. People use energy in quite different ways, and let's take 3 examples. An elderly person with regular habits will have quite predictable consumption. A young family might have a well-defined routine based on school and work hours, but with some variability around that. And a student flat share will have a very variable and unusual behavior. How do we identify their consumption patterns within the smart meter data? So with Facoetti, I developed a proof of concept of how we can tackle this sort of question. I analyzed publicly available smart meter data representing half-hourly consumption over a year for a few thousand households in London. And what I'm showing here is the average daily consumption profile. As you expect, it's lower during the night, higher later in the day. But I'm going to show you how we can learn how people behave differently from that. So to understand what the typical consumption patterns are, I consider the average profile for each household over a year. And using a clustering algorithm, I identified 5 groups corresponding to 5 typical behaviors. The first has high usage spread throughout the day. And then we have 3 that have a fairly sharp peak at different times in the morning, in the afternoon, or later in the evening. And the last one is a fairly flat profile. This is a good starting point, but we actually want to understand the big amount of data produced by smart meters each day in each household, which is a lot of data and it's quite spiky and quite noisy. So to analyze it, I used autoencoders, a kind of neural network that learns a compressed representation of the data and extracts relevant features from it. And here on the right, I'm showing a relatively simple model that compresses each household day to a point in a 2-dimensional space. And the main feature it learns is if there is a peak, and different areas in the space on the right correspond to different times of the peak during the day. Based on this, we can build more complex models tailored to specific commercial applications. As an example of a commercial application, I devised a simple scoring system that tries to capture how regular a consumer's behavior is. This is interesting for the energy companies because it can help them to manage the risk involved in buying energy in advance. And without going into too much detail, the score is based on the insight I showed you before, and it's a number between 0 and 1 that summarizes how well each day fits in a typical behavior for each household. And so going back to the example households from earlier, we can expect the elderly person to have a low score, let's say 0.1, the family with children to have an intermediate score around 0.5, and the students to have quite a high score around 0.9. But let's see some actual profiles from the data. So these are 3 households picked from the data with very different score. The first one has a low score of 0.07, and you can see it has a very consistent, very regular, very predictable behavior. The second one has an intermediate score of 0.68, and we can see there is some kind of routine in there, but with a lot of variability in the nights, for example, in the evenings. And finally, the last one has a high score of 0.88, and they have very irregular behavior. So to summarize, I talked about how I use clustering to segment consumers based on their typical behavior. I showed how we can use neural networks to extract relevant features from smart meter data sets and quantify how regular a consumer's behavior is. And in the future, we can build on this to develop more complex models tailored to specific commercial needs, such as tariff design. Thank you for listening.